Let us begin the session 3 with a quick recap. Types of mixtures we learned about homogeneous mixture and heterogeneous mixture. We discussed about the points that we already learned. Homogeneous mixture, which has a uniform composition. Particles of the mixtures are not visible and through naked eyes. The particles cannot be separated by filtration because we cannot decide which are the substances present in the mixture. Mixture is stable. What do you mean by stable? Stable means the particles of the mixture is not getting settled down. It is in the medium. So particles cannot be separated by filtration and the mixture is stable. Particles do not settle down. The path of the beam of light is not visible in the mixture. This is very important. When you observe the light passing through the solution, the path of light is not visible because the particles of the solution is very small in size. It is less than 1 nanometer, so that it will not scatter the light passing through the solution. So the path of the beam of light is not at all visible in the case of a homogeneous mixture. For example, salt in water, mixture of copper sulfate in water, potassium permanganate in water, sugar in water, all these are examples for the homogeneous mixture. Next is heterogeneous mixture, which is not having any uniform composition, that is non-uniform composition. Particles are visible by the naked eyes. We can separately visible what are the substances, what are the components present in the mixture, and the particles can be separated by filtration. We can separate the components through the filtration. And the mixture is unstable. When you keep the solution or mixture for some time, the components will be getting settled down in the bottom. So that is, the mixture is unstable in the case of a heterogeneous mixture. And what about the path of beam of light? When the beam of light is passing through the heterogeneous mixture, these particles or components present in the mixture, which is big enough to scatter the beam of light. So we are able to see the path of beam of light through a heterogeneous mixture. It is visible. So example, mixture of salt and sand, mixture of sulfur and iron filings, mixture of oil and water is an example for the heterogeneous mixture. Next we will discuss about the types of mixture. Mixture is classified into 3 types: solutions, suspensions and colloids. So this is based on the particle size of the solution. So based on the particle size of the solution, which is classified into true solution, colloids and suspension. First of all, we discuss with the true solution. What are true solution? True solution, true. What do you mean by that true? It is true solution is a homogeneous mixture of 2 substances. 2 components will be there, that is uniformly made up of. So we cannot identify the different substances present in the mixture. So that is called a homogeneous mixture. True solution is a homogeneous mixture of 2 or more substances. So here there are 2 components for a true solution. One is solvent, another one is solute. So what is the meaning of solute? The component which is present in smaller quantity, it is known as solute. The component which is present in larger amount, that is called a solvent. Solute and solvent mix together to get solution. So which are the 2 components of solution? One is solute, another one is solvent. So for example, solution of salt in water, solution of sugar in water, copper sulfate in water, iodine in water, tincture of iodine. It is called tincture of iodine. Iodine water, that is solution is named as tincture iodine. Soda water, etc. are the examples for the true solutions. So remember, true solutions are the homogeneous mixture of 2 or more substances. Which are the properties? Let us discuss the properties of the true solution. True solution is a homogeneous mixture. Number 1. They cannot be seen by the naked eyes. We cannot see the components of the mixture, true solution. Solute particles cannot be separated by filtration. As they are not visible by the naked eyes, we cannot separate the components of the true solution. The solute particles do not settle down. That means they are stable, and the solution is stable. The solute particles cannot be separated by filtration. Solute particles do not settle down, and the solution is stable. Particles do not scatter a beam of light passing through it, and the path of light is not visible in the solution. This we have discussed in the case of homogeneous mixture. As the true solution is a homogeneous mixture, we will show the properties also just like that. So solute, what is the definition of solute? Substance which is present in smaller quantity is known as solute. The substance in the mixture which is present in larger volume, that is called solvent. So here the example, solute plus solvent gives the solution. Which are the components of solution? One is solute, another one is solvent. So here example is given, copper sulfate, blue colored crystals, solute. This is called solute, and solvent in which it is dissolving, that is water. So water is a solvent here. Here a pinch of crystals are added to the solvent, 100 ml water. So here pinch of crystals, that means small quantity of the copper sulfate crystals are added to 100 ml water to get the copper sulfate solution. So this is blue colored solution is the true solution. Can you identify the separate components from this? No, we can only see the blue color of the solution. So we cannot identify the separate components present in the solution. Children, what are we discussing now? We are discussing the category of mixtures, that is true solution. So what are the components of true solution? Solute and solvent. Solute plus solvent gives solution. Now let us understand about disperse phase. Let us understand about dispersed phase and dispersion medium. So in the case of a true solution, what is dispersed phase? What is the meaning of dispersed phase? The phase in which the particles are scattered is known as dispersed phase. Which phase is scattered throughout the solution? That is solute. So in the case of a solution, solute is the dispersed phase. The phase in which is in more quantity, that is a medium, that is called dispersed medium. So which is the dispersion medium in the case of a solution? It is solvent. So solute plus solvent gives solution in which solute particles are the dispersed phase and the medium, that is solvent, is the dispersed medium. Let us discuss how we are preparing saturated solution and unsaturated solution. Solution, how we are making? We are putting solute into the solvent. Yes. So first of all we are discussing how to make an unsaturated solution. The word meaning is understanding from this only. Unsaturated means what? It is not reached the saturation level. So here the solution is preparing by adding the solute. Solute, if you are taking 100 ml water and adding solute into it and stirring with a glass rod, we are stirring and we will get a solution. And we can add on this solute into the solution so that it is getting dissolved. So we are getting a solution in which more and more solute can be added. There is no limit reached. So that solution is known as unsaturated solution. We can add more and more solute into it. It's not reached its saturation level. If you are adding, furthermore adding, it getting dissolved. So that is known as an unsaturated solution at a particular temperature. Here temperature condition is very important. If you are increasing the temperature, solubility increases. Let us discuss what you mean by solubility. Solubility of a substance is the amount of the solute present in a given temperature. So if you are adding solute into it, if you are raising the temperature, the solute will dissolve very faster. So at a particular temperature, how much solute is getting dissolved, that is very important. So in order to prepare an unsaturated solution, we can add more and more solute in that particular solution at a given temperature. Next is saturated solution. Here the solution is reached the saturation level. We cannot add more solute into it. If we are adding more solute into it, that will be settling down in the bottom of the beaker. So that is called a saturated solution. This all, remember, we are dissolving this solute at a particular temperature. The temperature is constant here. Let us watch one video about how to make this unsaturated and saturated solution.
Solutions like sugar in water has two components. The two components of solutions are solute and solvent. Solute is a substance that dissolves in solution. It is usually present in small amounts. In this mixture, the solute is sugar because sugar dissolves in solution and is usually present in small amounts. Now, let's talk about the solvent. Solvent is a substance that dissolves a solute. It is usually present in greater amount. The solvent in this solution is water because water dissolves sugar and is usually present in greater amounts. Between solute and solvent, we will focus on the solute. The ability of solute to dissolve in solvent is what we call solubility. Solubility is a maximum amount of solute that can dissolve in a given amount of solvent at a certain temperature. The amount of dissolved solute produces three types of solutions. Here's an experiment about the three types of solutions based on the amount of dissolved solute in solvent. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Its color is lighter than saturated and supersaturated solutions. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. The color of saturated solution is intermediate between unsaturated and supersaturated solutions. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. Its color is darker than unsaturated and saturated solutions. It has an excess solute or sugar which can no longer dissolve. Let us sum up. The three types of solutions are unsaturated, saturated, and supersaturated solutions. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. The color of unsaturated solution is lighter than saturated and supersaturated solutions. The color of saturated solution, on the other hand, is intermediate between unsaturated and supersaturated solutions, while the color of supersaturated solution is darker than unsaturated and saturated solutions. Supersaturated solution has an excess solid which can no longer dissolve.
Let us discuss the types of solution. There are 5 types based on the dispersive phase and dispersion medium. First of all, solid and solid in solid solution. Here both dispersive phase and dispersion medium both are solid. For example, alloy. Alloy is an homogeneous solution or mixture of the two metals. For example, this bronze. For example, alloy is an homogeneous mixture of two or more metal. For example, stainless steel. Stainless steel is an homogeneous mixture of two or more metals like which are the metals present in the stainless steel? Iron. Iron is the main metal present in there. And chromium and nickel. And then bronze. Bronze is a mixture of the copper and zinc. So these are solid in solid solution. Next is solid in liquid solution. So here the dispersed phase is solid and dispersion medium is liquid. For example, solution of salt in water, sugar in water, copper sulfate in water, all these are solid in liquid solution. Next is liquid in liquid solution. Here the both the dispersed phase and dispersion medium both are liquids. For example, oil in water, acetic acid in water, ethanol in water, both are liquids. Next is gas liquid solution. Here the gas is the dispersed phase and the liquid is the dispersion medium. For example, soda water. Here carbon dioxide is a gas which is dissolving in water, will get soda water. So dispersed phase is CO2 and dispersion medium is water. So that is a gas liquid solution. Next is gas solution is also there. That is dispersed phase and dispersion medium both are gaseous stage. So for this example, air is a mixture of different gases present in it. For example, hydrogen, oxygen, carbon dioxide, nitrogen, many gases are present in the atmosphere. So air is an example for the gas solution. Let us watch one video about the types of solution which is describing solid, liquid and gas solutions.
Types of solutions. In a binary solution, components can be either solid, liquid, or gas. There are three types of solutions: gaseous solutions, liquid solutions, and solid solutions. In gaseous solutions, gas is the solvent. They are categorized as follows: solid in gas. For example, camphor vapor in nitrogen gas. Liquid in gas. For example, water vapors in air. Gas in gas. For example, mixture of gases or air. In liquid solutions, liquid is the solvent. They are categorized as follows: solid in liquid. For example, salt in water or sucrose in water. Liquid in liquid. For example, mixture of miscible liquids. Gas in liquid. For example, aerated drinks. In solid solutions, solid is the solvent. They are categorized as follows: solid in solid. For example, alloys. Liquid in solid. For example, mercury in zinc. Gas in solid. For example, adsorption of gases on metals.